Okay, so next we move on to the part 2 of this project, which is code execution. So next one. Okay, so the documentation on the code that we use. The code is written to check the runtime for two computer CPU used for this project. First, we will initialize the X value to 3 and the ECX register to 100 to indicate there's 100 loop. Then we will call the get m seconds function to get the current runtime for the CPU and store it in the variable msec1. The L1 label marks the start of the loop of a loop that will be executed 100 times. Inside the loop, the program will calculate the value of the equation for the current value of 100, the current value of x. First, multiply x by itself using the mul instruction and multiply the result by 3. The result of this is stored in the EBX register. The program then calculates for 2 times x by multiplying x by 2 and stores the result in the EDX register. Next, the program adds the two result EBX and EDX together, adds 1 to the sum and decrements ECX by 1. The JNZ is used to check if ECX is 0. If ECX is 0, it jumps back to the L1 label and continues the loop after the loop has finished. The program calls the get m seconds function again to get the current CPU time in m seconds and stores it in msec2 variable. The program subtracts msec1 from msec2 to calculate the difference in CPU time and stores the result in the CTE variable. The output for this program includes the benchmark information, the value of the sum, the CPU time before and after calculation, and the CPU time taken for the calculation.
Okay, now moving on to discussion, we obtained the main objective, which is to compare two CPU runtimes between two computers, which are HP Pavilion X360 convertible and ID Center 307 IAB7, while also examining the factors that contribute to CPU performance. The findings reveal that HP Pavilion X360 convertible exhibits slower CPU runtimes compared to the Idea Center's 07 IAB7. This observation suggests that the Idea Center computer outperforms the HP Pavilion computer in terms of the CPU performance for the given task. To understand the reason behind this performance difference, it is necessary to analyze several aspects that influence CPU performance. One of them is in assessing data processing efficiency and speed is the CPU speed, which is typically measured using CPU benchmarking. According to the benchmarking findings, the CPU in HP Pavilion is inferior to the Idea Center computer, which aligns with the observed CPU runtime of the HP Pavilion X360 convertible. This finding further supports the notion that Idea Center performs better in terms of the CPU performance. Another significant component influencing CPU performance is the CPU generation. This HP computer incorporates an i3-10110U processor, while the Idea Center computer features an i5-12400 processor, which belongs to a much newer generation. As a result, the Idea Center computer is expected to deliver better performance compared to the older generation CPU, as advancements have been made in the processor. Additionally, the differences in the cache capacity, architectural design, and power efficiency can also contribute to the performance disparity. The number of CPU core is also another important factor when it comes to multitasking and processing speed. The HP computer has two cores, whereas the Idea Center computer has six cores, which is triple amount of the cores in the HP computer. To gain a comprehensive understanding of the performance differences, it is important to consider other factors such as clock speed and overall CPU efficiency in addition to the core count. In this particular case, the Idea Center computer has a faster clock speed, which is 2.50 gigahertz, compared to the HP Pavilion computers, which is 2.10 gigahertz. Furthermore, it is crucial to highlight that the observed differences in CPU performance are tasks and workload dependent. Different tasks or applications may produce different results, leading to varying performance between the computers. Overall, the results of this investigation indicate that idea Center 3 07 IAB7 outperforms HP Pavilion X360 convertible in terms of CPU performance, resulting in a much shorter runtime. CPU speed generation, core count, and clock speed are all the factors that contribute to the reported performance variations. While analyzing CPU performance for specific tasks and applications, it is important to consider these factors. However, it is important to note that this study solely focused on CPU speed and did not take into account other components such as memory, storage, and GPU, which can also impact overall system performance as a whole. To gain a comprehensive understanding of system performance, it is necessary to investigate the interaction between these components and the CPU. These insights can help us better understand CPU performance within the given workload context. Future research and experimentation can explore additional aspects and benchmarks to further enhance our understanding of CPU performance and its impact on overall system performance. That is all for me.
Okay, so next is the conclusion for this whole project. CPU performance is influenced by various factors such as the CPU's generation, clock speed, number of cores, and threads. We have evaluated two different CPU models through synthetic benchmarking tools, as this method allows fair comparison between the CPU models and the result produced is dependable. Furthermore, we implemented a real-life scenario that can help us to evaluate and understand CPU performance more accurately. We have run a code that calculates a math equation to measure the time taken for the CPU models to process the instructions. This approach ensures that our results on CPU performance are not only based on benchmark tools, but also a practical scenario. Consequently, it is found that a CPU with a newer generation, greater clock speed, and a higher number of cores and threads executes and runs program instructions better and faster.
Okay, now we will continue with reflection for each member. I will start first. From this project, we can see there was a significant difference in performance between the two computers chosen for this project. The higher-end computer outperformed the lower-end one in both benchmarks, which is CPU-Z and Cinebench R23. This observation highlighted the impact of hardware specification and their effects on overall performance. It shows the fact that investing in better hardware can lead to a more efficient and faster computing experience.
Okay, so next is my part of the reflection. This project makes me realize how benchmarking is important for measuring the performance of different computers with different aspects. Benchmarking allows users to make informed decisions when choosing a computer that meets their specific needs and requirements. Benchmarking of computers can be done by comparing different aspects such as graphics, processing power, memory capacity, storage speed, and overall system performance. In this project, we use two different softwares to compare different aspects, which is CPU-Z, which compares the real-time measurement of each core's internal frequency, and Cinebench R23, which compares CPU and graphics performance. By evaluating these various aspects, user can determine which computer will best suit their needs, whether it be for gaming, graphic design, or everyday tasks. In addition to benchmarking, it is important to compare CPU specifications when choosing a computer because they have a direct impact on the speed of computational tasks. This can be done by executing a complex code with a big number of loops to compare the runtime of different processors.
Now, moving on to my part of reflection. From this project, I understand how to utilize benchmarking softwares to determine our device's CPU performance, such as Cinebench and CPU-Z. I now understand how CPU performance may affect CPU runtime, which in turn affects other performance in far more sophisticated programs and softwares. I believe that in the future, I will be able to check devices with far more accurate observations and comprehension of their quality in terms of the CPU performance. I also learned about runtime by executing the code in Visual Studio, to analyze the performance of our CPUs in various devices, which have been mentioned before. Overall, good CPU performance will lead to speedier program execution. That is why I emphasize the significance of high quality CPU performance in our personal computers.
My reflection. Through this project, I learned how to use benchmarking tools to compare and evaluate the performance of different CPU models. I learned how CPU works and process both single-threaded and multi-threaded instructions by distributing the tasks among the cores. At first, we encountered a problem in implementing the code, but we managed to overcome it and was able to measure the time taken of the CPU. It is interesting that we can also see the CPU performance by providing a task in real time. Overall, this project has provided me a better understanding on how CPU performance is impacted by multiple factors, and this information can be a help when I want to buy a new computer. That's all from us. Thank you.